Okay, good morning everyone. It's a pleasure to be here. I'm Ugo Pattacini, technologist researcher in the ICAP Tech facility led by Marco. And as anticipated, I'll be here to cover the software part. To this end, let me grab the opportunity to introduce all the research topics as well as software tools that I'm being using in our CRIS building, CRIS Center at IIT, which has been launched 1 year ago, as Marco said. At CRIS, we have 3 research lines plus our facility, and this is a quite incomplete list of the research topics that we've been pushing at CRIS, ranging from, of course, platform development and system integration, which are the main focus of the facility, and going also to learning objects, tool use through interactions, doing some sort of sophisticated dynamic control under external disturbances, doing also assistance rehabilitation, mobile manipulation, and also, last not least, something more close to the electronics hardware. So there is a research line called event-driven perception for robotics that is active on event-driven cameras. So the first, okay. This is the overview of the humanoid sensing and perception group led by Lorenzo Natale. As you can see, basically they're very active on the learning aspects of the research in a way that learning is performed through interaction. So both with ICAB and R1, as you can see, there is an experimenter interacting with the robot, teaching on the fly objects, correcting on possible mistakes that the robot may do. And then once the objects is acquired, we can basically they use this representation to perform a manipulation. And for doing manipulation, the group is also active on pose estimation for correcting errors via visual servoing and identifying object pose in 6-dimensional space using state-of-the-art techniques. And they do also 2D navigation, although it's inherited from the raw stack. So we just built a wrapper over it. In terms of software tools, this group, of course, as usual, benefits from off-the-shelf libraries, especially in the perception. So we basically resort to OpenCV, PCL, VTK for visualization of scientific data, and this is for visions and visual processing. And then TensorFlow, Caffe for what concerns machine learning. And on top of this, then we basically building on our own software tools for kinematic control, trajectory planning, inverse kinematics, and then there is also IPOpt, which has been heavily used for doing optimization. And for what concern object modeling and grasping, the HSP group has designed and realized a library for geometric representation of objects, on top of which then we perform power grasp, both with ICAB and R1. So the idea is to basically develop software with a high level of abstraction so that we can factor out the specificities of the hardware. All the tools are basically hosted publicly on GitHub in our organization called Robotology. And there is a mention of honor for interaction learning, because basically it's an open source software tool that we made available from GitHub that basically inherit all these services, and throughout time we basically use this to build on all our demos. So it's very useful for experienced researchers, but also for newcomers. So by starting from this point, you can have a ready-to-be-used demo where the robot can learn objects on the fly on a tabletop scenario and can interact with the experimenter. So it's a very convenient starting point for instance, for a TERRINet trainee participant, let's say. And then there are tools also for pose estimation, for Bayesian filtering, visual servoing, and 6D object tracking. I just put list of the repository where you can find the code plus API documentation. Then the second research line is called Dynamic Interaction Control, led by Daniele Pucci, which is a group very active instead on dynamic control under the presence of external disturbances. They work on the HICAP in this case. They've been mainly focusing on three different axes of research: teleexistence, human-robot collaboration, and high-aerial humanoid robotics. Let me say that the important thing is that they basically trying over time to use a lot the models in order to make a simulated experiment very close to reality. As you can see on the top left corner, there is a quite one-to-one correspondence between the experiment run within Gazebo and the one run with the real physical robot. The tools employed in this group, of course, resource to standard dynamic control libraries for free-floating robots in this case, because we are concerned with walking. Human dynamic estimation using a gyroscope mounted on a suit that experimenter can wear. And then concerning off-the-shelf libraries they use IPOpt and copioasis for doing nonlinear constraint optimizations or quadratic programmings, depending on the situation. And in this case, they basically, importantly, it's important to notice that they're pursuing a research methodology that is based on model-driven development. So they really design their software within Simulink, and then they use MATLAB, for instance, MATLAB embedded coded to produce C++ code, production code that can be deployed in the computer or even on board. We are working to basically deploy also the code within the embedded board of the robot. So the developer stay at this level. Is not concerned with writing code, C++ code. Okay, so it's much, let's say, high level design. Okay, so you can share model instead of sharing code, and you can target the code to the processor, the CPU, or the FPU you are dealing with. Okay, thanks to the MATLAB suite. For what concerns the third research line called EDPR, Event-Driven Perception for Robotics, this is very close to the hardware, as I was mentioning at the beginning. And so there is a completely different paradigm of vision, which is based on event rather than frame. And so Chiara Bartolozzi, the head of this group, is basically supervising her postdocs and researchers to basically try to implement on this new, completely brand new paradigm the standard techniques that are available on frame-based cameras, like optical flow, cluster tracking, filtering, particle filtering, and so on and so forth. You can see here on the left an example of that is concerned with the independent motion detection using event-driven cameras, tracking of a ball on the right using still event-driven cameras. And we have also here the software which is publicly available on the Robotology organization on GitHub. For what concern, we don't do much of research as a facility, but we are involved in several projects and collaboration with institutions in Italy. In particular, we have an ongoing collaboration with the Dognocchi Hospital for trying to use R1 as an assistant, basically intelligent assistant during rehabilitation in motor exercises. And in this case, the idea is basically to help patients to rehabilitate his upper limbs. And to this end, of course, we make use of open pose to detect the skeleton into the image. And then our duty, our task is to transform this 2D representation into a 3D in 3D space. So we have to perform human 3D pose estimation and perform also action learning based on LSTM. These are basically the two topics that we've been pushing in the ICAP Tech. And also here, participants can collaborate publicly to our repository on GitHub. All this research and activities is carried out thanks to the use of a middleware. Of course, as you may know, IIT is the house of YARP, so the choice was somehow given. But nonetheless, compared for example with ROS, YARP comes with a nice bunch of perks. Let me just term a few. Well, it's a lightweight C++ library, so we favor humble approach. It's not grabbing massively your system like ROS, because we depend on a very few external libraries. By the way, using Swig, we can provide bindings to high-level scripting languages like JavaScript, Python, Lua, MATLAB, and so on and so forth. And in terms of protocols and interfacing to hardware, so motor sensors, YARP is much easier than ROS. So nowadays, there's still room for YARPers to exist, okay? Even though we cannot compete, of course, with the ROS community because it's huge, it's vast, it's worldwide. There are a large variety of tools and libraries available. So that was the reason why we basically made ROS our friend. So YARP can natively speak ROS thanks to an extended API. So that ROS-like concept like nodes, publisher, subscriber are also available within YARP. And you can see a sketch, a diagram depicted on the slide representing the software architecture of the Walkman when we basically participated to the DARPA challenge some years ago with the advanced robotics teams. As you can see that software-wise, at least, was a great experience because we came up with a mixed approach where YARP was used to interface hardware at low level, while we took advantage of ROS to inherit all the planning at high level, basically. But YARP also offers something that in ROS is not available, and is related to the composition and coordination of high-level architecture made of to design basically high-level behavior. For what concerns composition, when you are tasked with the goal of creating complex behavior made by simpler building blocks, in YARP you have available YARP Manager, which is a GUI where you can build your architecture by drag and drop modules connecting like you would do in Simulink, for example. It's not just for building the architecture, it's also for deploying in at runtime your structure, so you can deploy your schema in a distributed system, and you can see live on the fly what's going on. So the connection, if the module is running okay or not, and you can query the system. So this is a part that is completely missing, at least as far as I know, in ROS. And for what concern coordination, also there are a couple of other GUIs that enable users to basically easily and visually design final state machines or behavior trees to coordinate high-level application, let's say. Okay. When it comes down to simulator and data sets, of course, if you don't want to work with the physical robots, you can reproduce experiments on a simulated one using all the suite of tools we made available, dataset player, recorder. We have simulators, so we basically been phasing out our old OD-based simulator in favor of the most modern Gazebo and PyBallet. Gazebo is especially used for doing dynamic interaction control, basically, while PyBallet is employed for enforcement learning, manipulation, and so on and so forth. And recently we we also publish datasets, big datasets on for the machine learning community, which is called ICAP World, which comprise a large datasets of image taken from the robot camera in a completely different settings with respect to the static image challenge. In skill requirements, basically, if you want to play with a real robot, of course, you need to be a bit knowledgeable in Linux and a bit of basic C++. Then it very much depends. But as I said before, if you use a Zwig, you can have access to YARP and our infrastructure also from different entry points. And then depending on the group you may work with, you might need to have a basic knowledge also in vision processing, deep reinforcement learning if you work on humanoid sensing perception, control theory, of course, and MATLAB Simulink knowledge if you work with a dynamic interaction control group, and of course signal processing so if you want to put your hands on event-driven cameras and C++. Concerning training, of course, we do have standard wikis, tutorials, API documentation as usual, accessible from our websites, but lately, since a couple of years, basically, we've been putting a considerable effort in order to make a step forward in this direction and transform the training experience in something more appealing, more exciting, and also more effective. So you can somehow sort of think of solving training beforehand, for example. And you can do training remotely. To this end, we make use of GitHub Classroom, which is a free of charge for academics service made available by GitHub. And so it's a complete infrastructure that easy this process. So teachers or tutors basically come up with a list of assignment. An assignment is a repository in GitHub that contains instructions for the trainees or for the students, plus a starter code. Starter code is a code that can compile usually, but contains gaps that are required to be filled in by the students. So the students inherit through the GitHub Classroom this repository. It's a sort of fork, and then is asked to complete, to turn in the solution in terms of a push to the repository. And then as soon as there is a push, we can basically test the solution using our simulator. Okay, there is an automatic test run used based on our testing framework, which might be RTF or block test in the future. And this test can be run locally or also remotely. So basically, we prepared in the last 2 years lots of assignments covering all the disciplines we are active in. So inverse kinematics, basic vision, machine learning, dynamic control. And we basically hosted all this in a GitHub organization called VVV School, because we use this infrastructure for the winter school in humanoid programming. And thanks to GitHub Classroom, the teachers or tutors have a dashboard from which you can basically manage all these assignments. And we prepared also a gradebook so that the teacher can have a quick summary of how the student is performing. Okay, for each assignment you can have a grades or just a simple pass, fail. And according to the EdTech community, GitHub Classroom is really catching on. So it's emerging as a tool that really supports teaching nowadays. You can even use GitHub, this mechanism to do audition projects. So if you aim to evaluate a candidate for your job post, you can challenge the candidate with an assignment that needs to be basically complete in 1 week, for example. Okay. And so training within the TERRINet context framework can be done beforehand using this system. Okay. Then what is missing is for newcomers is also difficult to install and prepare the system beforehand. So installation is still a painful, a burden for newcomers. So we basically been taking advantage of the new online IDE that are available out there. And there are available a bunch: Gitpod, Eclipse, Visual Studio Online. And using a Docker recipe, you can attach a Docker recipe to this one of these. We've been using Gitpod in this example, so that what is needed by a newcomer is just a browser, no installation at all. Okay. So from the browser, you can have access to a fully fledged Ubuntu system where there are components pre-installed. And this is very useful for crash courses, for example. Indeed, we've been using this infrastructure, so GitHub Classroom, and potentially also, next time, also the online Cloud IDE for all these editions. So in the last 3 years basically, we launched 2 editions of the Veni Vidi Vici Winter School in humanoid robot programming. It was really a success because aside the frontal lessons, we had hands-on tutorial and assignment using GitHub Classroom, so with a very practical experience of the students, and then before going to the real robot, basically. And then we also run crash courses, 2 days crash courses. So undergrad was able in 2 days to control an iCab head, dealing both with the control part and the vision part. So just in two days was from 0 to hero, okay? And it's important to highlight the fact that next winter school will be basically founded by TERRINet as well. So it's going to provide a handful of grants for students. And it's going to happen in March, starting March. So if you have any question, I'll be happy to take. Yes. Whoa. Yes, the idea, let me go back to the video. Yes. Indeed, it's an amazing idea that Daniele had while dreaming, maybe. Where is? Whoa, it's okay. This one. So now we have, where is the? Okay, it's just taking some time. So the idea is to use, to extend the locomotion in order to overcome obstacles that by just walking is impossible to get around. In context, for example, for disaster recovery. And what Daniele is studying with this group is to attach basically turbines to the iCab. It's not starting. And study the standard standard flying mode in with the no, yeah, there are. We didn't show, but we have turbines, so it studies identifying how a turbines react to command. And Marco, our basically facility, already came up with a custom part to attach turbines to the robot. Yes, so we have a video actually, but I don't have it here. Maybe if you reach out to Daniele Group, you can have yes. There is, if you visit this URL, there are more info on this. Yeah. It's now running. Let's see. But okay, you see the video.